All right, we're going to start free response question number 2, which, as you can see, is from the 2009 Form B test, problem number 3. So let's jump in and read the question. And just a reminder, you should have spent time solving this on your own. Hopefully, you got all your answers correct. You're just using this to correct your work and fix anything that you got wrong. So let's read through the question. A French study was conducted in the 1990s to compare the effectiveness of using an instrument called a cardiopump with the effectiveness of using traditional cardiopulmonary resuscitation (CPR) and saving lives of heart attack victims. Heart attack patients in participating cities were treated with either a cardiopump or CPR, depending on whether the individual's heart attack occurred on an even-numbered or an odd-numbered day of the month. Before the start of the study, a coin was tossed determining which treatment, a cardiopump or CPR, was given to the even-numbered days. The other treatment was given on the odd-numbered days. In total, 754 patients were treated with a cardiopump, and 37 survived at least 1 year, while 746 patients were treated with CPR, and 15 survived at least 1 year. So part A, it says the conditions for inference are satisfied in the study. State the conditions and indicate how they are satisfied. So just like in the previous video, for the conditions, there's just going to be 2 that we're going to really focus on for the AP test. We're not going to do the 10% condition anymore. We're just going to do the random and normal because that's what they're going to be looking for. So the first thing I want to do is define my parameters so I know what P1 and P2 represents. So P1 represents the survival rate for people that had the cardio pump treatment, and then P2 represents the survival rate for the sample that had the CPR treatment. So in our conditions, we want to make sure we name what type of test it is, just like we always do for a test or for a confidence interval. So we're going to say the conditions for a 2 sample, because we're dealing with 2 samples. 1 sample is the cardio pump, 1 sample is the CPR group, and then it's a proportion because it's the proportion of patients that survived. It's a z-test because remember, a z-test always goes with a proportion, test, or confidence interval. So our conditions that we check random. The subjects were randomly assigned and independent. That means, again, independent. One individual doesn't affect the outcome of another. So that random condition is met. Then for normal, we have to do the formula n times p, n times 1 minus p needs to be greater than or equal to 10. As you can see, all those check out, so we know that's approximately normally distributed. If you look down here, I just calculated our sample proportions. A lot of times they're not going to give it to you calculated out, so they'll give you as raw data, so you have to do those calculations. A lot of people, when we did this test, missed points on that and got confused. So make sure that you're always taking the time to figure out what your sample proportion is from sample 1 and sample number 2. All right, let's move down to part B. So it says perform a statistical test to determine whether the survival rate for patients treated with a cardio pump is significantly higher than the survival rate for patients that got CPR. Got cut off there, but it's the CPR group. So we already did our conditions. So as you can see, as I wrote down, just to be super clear, I put C above because that was another part of the problem. If we didn't have part A, we want to make sure we write the conditions as part 2 of our test. But we already did that, so we don't have to worry about it. First part, we want to identify our hypothesis test. And if we didn't have part A, we will make sure that we would correctly identify what P1 and P2 represents. But since I already did that for, let's see, only did that for the top, what P1 and P2 represents, then I don't have to do it again. So for our hypothesis, P1 minus P2 needs to be greater than or equal to 0. Remember, for our null hypothesis, it's always going to be equal to 0. So really easy. Now for alternative, we want to read through the problem. So it says they're trying to test whether the cardiopump group is higher than survival rate. So let's go back and look and see what P1 was. So P1 was the cardio group, and P2 was the CPR group. So if we subtract those two and cardiopumps higher, then our difference is going to be greater than 0. So our greater than sign is going to be on our alternative hypothesis. So then for condition, we want to say it's a 2-sample proportion z-test. Then we already did our conditions, so we're going to jump ahead to the actual calculation of your z-score and p-value. So remember, this first part of the formula right here is dealing with, you take your 2 sample proportions and subtract them from each other, and then minus that from 0, which comes out to 0.029. Then we plug in our standard deviation formula right here. Now make note of this. I'm going to put a big star right here next to this part of the test because this is different than the confidence interval. Okay, proportions for 2-sample are a little bit tricky because the standard deviation is going to be different than what the standard error is on the confidence interval between the test and the confidence interval. So remember, for a test, we're assuming we're testing against if there was no difference. So we combine the results from the 2 different samples. So I use this notation right here, PO, so the proportion from our null hypothesis, as if there was no difference. So you just add your 2 numerators together to get 52, add the 2 sample sizes together, you get 1500. So then your new proportion comes out to 0.0347. And that's the proportion, if there was no difference, what the proportion would be if we combine those 2 different groups. So that's what we plug into our p-values on the top part of our standard deviation formulas. And we subtract that from 1 to get these other 2 parts. So in your significance test, the numerators on your standard deviation are always going to be the same. What's going to be different is the sample sizes, if the sample sizes vary, like they do in this problem. So sample size 1 was 754, so we put that on the bottom here. And then 746 was the sample size for sample number 2, so we put it there. So then that bottom number should come out to 0.0095. Get practice doing that in your calculator. If you're having issues with that, you can email me and I can send you a screenshot of what it should look like. If we have enough people having issues with it, I'll record a separate video with the calculator to show you exactly how to put that in there. But that should come out to a z-score of 3.05. Remember, our z-scores, we only need to include 2 decimal places. If you want to include more, that's fine. But for this example problem, I'm only going to include 2. So 3.05. So then I'm going to convert that using normal CDF. So my lower boundary is going to be my z-score, which is 3.05. So I want to make sure I label that. Oops. Label that as our z-score. Upper boundary is going to be positive 1,000 because, again, we're trying to find that tail value. And that gives us a p-value of 0.0011. So going in our interpretation, it didn't give us a significance level, so we just assume that it's going to be 0.05. So our interpretation is, since our p-value of 0.0011 is lower than 0.05, we have statistically significant evidence to reject the null hypothesis. We have evidence the cardiopump is more effective at saving heart attack patients than CPR. Okay, so since our p-value is below our significance level, then we can reject the null hypothesis, which was there's no difference between the 2 treatments. So that means that we have evidence that the cardio pump is a lot more effective than the CPR treatment. Okay, so again, with your interpretation, that first sentence should be including your p-value against your significance level, and that second sentence should include your interpretation in context with the problem. As far as scoring for this problem, essentially it's pretty straightforward. You get essentially correct for 4 different parts. So you got your conditions, hypothesis, calculating your z-score and p-value, and then having a good interpretation for that. So we'll make sure you're including all of those different parts to that.